Hello student, I am Professor Devashish Bose, Head, Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar, Madhya Pradesh. Today, I am going to present a lecture of BSc 5th semester on the unit General Idea and Examination of Metallic Poison Part 2, which has been jointly prepared by myself and Ms. Priyanka Pare, PhD Scholar, UGC GRF at Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. So, let's start our discussion while taking a look at what we are going to learn today. So, today in Module 1, we will be looking at Introduction to the following metals: iron, lead, manganese, mercury, nickel, thallium. In Module 2, we will look at preliminary examination of all the above mentioned poison. Module 3 will deal about the confirmation examination of all these metals. Module 4, forensic importance of all the above mentioned metallic poison. Module 5, case study, and finally Module 6 will be our conclusion. So now let's start with Module 1. Introduction to following metals: lead, manganese, mercury, nickel, thallium. In previous lecture, you have learned about some of these metallic poisons. It is not possible to cover all the metallic poisons in one lecture because there are a lot of poisons covered in forensic science. Some of them are lead, manganese, mercury, nickel, thallium. So today I came with another knowledgeable lecture which is related to metallic poison. Let's start our lecture with lead. It tops the list of heavy metals. Some inorganic compounds of lead are introduced in this lecture. The first is lead acetate. This is also known as sugar of lead or salt of Saturn. In old days, it was used to sweeten wine. Some inorganic compounds like lead carbonate are used to correct things on paper. This is available in market in the form of pen, which is commonly called safeda or whitener. Lead nitrate is used in calico printing. Another one is lead chromate. It is bright yellow insoluble powder used as pigment. Some cases of poisoning have been recorded when it is used to color sweetmeats. Lead have also another inorganic compounds, but most of them are not poisonous to us, thus does not produce any type of casualty. The toxicity of lead is probably related to its affinity for cell membranes and mitochondria, as a result of which it interferes with mitochondrial oxidative phosphorylation and sodium, potassium and calcium. Acute and subacute poisoning. Some salts of lead are most poisonous. Lead acetate is one of them. It is the most common salt that causes acute poisoning. This salt also produces subacute poisoning. This type of poisoning occurs when small doses of lead acetate are taken repeatedly for a long time. Chronic poisoning. I would like to make you aware about chronic poisoning of lead because most of us in our daily routine comes in contact with things which contain lead. Do you know about that? Chronic lead poisoning may occur in the industrial environment due to inhalation of lead dust or lead vapors arising from burning of paints, battery, smoldering, glass blowing and polishing, enamel factories, dye, cosmetics, etc. It may also occur due to low dose consumption from drinking water supplied through lead pipes, food preservatives in tin container, food contaminated with lead during preservation, etc. Poisoning may also occur due to prolonged use of vermilion and cosmetics containing lead. Absorption of tetraethyl lead through skin is common in people who handle petrol or gasoline. Presently, in India, lead-free petrol is provided. Fatal dose and fatal period. Fatal period may be from 2 to 3 days. Treatment. Emesis may be tried to remove the unabsorbed lead from the stomach. Gastric lavage with magnesium or sodium sulfate is always advised. Calcium gluconate 2 gram intravenously is given because It relieves abdominal colic and also helps in deposition of some of the lead in bones. DMSA is an effective oral chelator and may be given to outpatients. Penicillamine 0.5 to 1.5 gram daily in an adult is an alternative oral chelating agent in those countries where DMSA is not available. Now we come to manganese. Manganese is a very common compound that can be found everywhere on the earth. Manganese is one of the 3 toxic essential trace elements, which means that it is not only necessary for human to survive, but also it is a toxic when high concentration are present in a human body. The uptake of manganese by humans mainly takes place through food such as spinach, tea, herbs, etc. The foodstuff that contains the highest concentration are grains and rice, soya, eggs, nuts, olive oil, green beans and oysters. The salt of manganese is potassium permanganate, which is also used as bleaching agent in textile factory to bleach clothes. In hospital practice, it is given to pregnant women as a aborificant illegally. In chemistry, potassium permanganate also used as an oxidant in chemical reaction. Other salts like manganese dioxide is used to make dry cell. Signs and symptoms include burning pain in the mouth and throat, abdomen, difficulty in swallowing, continuous vomiting, difficulty in breathing. Death generally occurs due to circulatory failure. Poisoning is rare. Tongue and pharynx are stained, generally black or dark brown. Treatment: calcium glucuronate or adenate, mercury. Including all metals in periodic table, it is the only metal that is present in a liquid form at room temperature. It has one of the best property that it exists in 3 forms: metallic, mercurous and mercuric. Metallic mercury, also known as quicksilver or para, is a liquid metal having a bright silvery luster. It exists in nature as the metal itself and as the sulfide. Mercury depresses cellular enzymatic mechanism by combining with sulfadiryl groups. There are different compounds of mercury like mercuric oxide, mercuric chloride. It is also known as corrosive sublimate and generally used as an antiseptic, which is quite common in clinical practice and is applied on cuts, abrasion. Dear student, you all are aware about sindoor. It is a religious practice. It is used by Indian married women on their forehead as a sign of marriage. In scientific term, sindoor or vermilion, generally known as mercuric sulfide. It is considered as non-poisonous. Other salts are mercuric sulfate, mercurous chloride. Fatal dose: mercuric chloride 0.5 to 1 gram per 70 kg of body weight. Mercurous chloride 1.5 to 2 grams per 70 kg of body weight. Fatal period: death may occur within a few hours, but it is usually delayed for about 3 to 5 days. Treatment: gastric lavage as indicated. Chelation therapy with BAL or penicillamine is the main treatment. Dimercaprol is given in deep intramuscularly at a dose of 100 mg every 4 hours for about 48 hours. In case of acute poisoning, in case of mercury poisoning, it may occur through inhalation while heating metal in a closed room or following gold refining in an enclosed area. Symptoms include coughing, dyspnea, fever, headache, gastrointestinal disturbance including metallic taste and blurring of vision. Chronic poisoning. We all are aware about chronic poisoning. It is a poisoning occurring from long time exposure from some poisonous substance. This type of poisoning occurs in factory workers who are exposed to vapors or dust of mercury while working. It is also seen in patients who use ointment for a long time which contain mercury. Symptoms of chronic poisoning includes the following, which are specific for mercury: mercuria, lentis may present in the form of discoloration of the anterior capsule of the lens of the eye due to deposition of mercury. Neurological toxicity is manifested by tremors, which are sometimes referred to as Danbury tremors. The advanced condition of tremor is referred to as hatter's shake because it was common in workers of that industry. Now we come to another metallic poison, that is nickel. Nickel is a very hard metal that occurs naturally in soils and volcanic dust. This metallic poison is released by the atmosphere by wind-blown dust, volcanic activities, combustion of fuel oil in vehicles, municipal incinerations, and industries involved in nickel refining, steel production, and other nickel alloy production. The form of nickel emitted to the atmosphere depends upon the source. Complex nickel oxide, nickel sulfate, and metallic nickel are associated with combustion, incineration, and smelting, and other refining processes. In an organism, it causes suppression of the uptake of zinc, copper, iron, manganese, calcium, magnesium, and sulfur. As these are suppressed by nickel, parts of DNA can be silenced, not mutated, leading to cancer. Reports of allergic contact dermatitis, pulmonary and respiratory effects are there. Poisoning is rare due to the metallic poison. Now we come to another important metallic poison, thallium. Thallium is a soft, white, heavy metal with a lustrous color present in D block of periodic table. The metal and its compound are highly toxic in nature. From the medico-legal point of view, important salts are thallium acetate. It is sometimes used in the treatment of ringworm of the scalp. It is colorless and odorless. Thallium sulfate. The salts are soluble, colorless, and nearly tasteless, and are therefore can easily be administered orally in food or drink. These qualities make it one of the ideal homicidal poison. Thallium is used in the manufacturing of optical lenses and scintillation counters also. Signs and symptoms usually appears within a few hours of ingestion in the form of nausea, vomiting, or abdominal pain. Sweat glands and sebaceous glands are destroyed and the skin becomes dry and scaly. Nail growth is impaired with the development of ridges, usually known as Mees line. Other symptoms include Bew line, white lines across the nails because of trauma. Skin disease, second one is Merkel line, white bands in the nail bed associated with hypoalbuminemia, and terry nails, white coloration of nails except for distal portion seen in cirrhosis. Fatal dose, usually fatal dose is about 1 gram. Fatal period, death may occur in 2 days and could continue up to 2 weeks. Fatal period, death may occur in 2 days or even after 2 weeks. Treatment, gastric lavage with Persian blue as it binds thallium in the gut and prevents its further absorption. Activated charcoal and saline purgatives can be given to enhance fecal excretion. Preliminary examination of lead. First of all, we need to digest biological material for chemical analysis. Following tests are performed for the examination of lead. In 1 ml of the test solution is added 1 ml of dilute hydrochloric acid. A white precipitate is obtained which dissolves on boiling and reappears on cooling. To 1 ml of the aqueous test solution is added 1 drop of dilute nitric acid and 1 ml of potassium iodide solution. A bright yellow precipitate is obtained. On boiling the content, the precipitate dissolves out, and on cooling, a golden yellow spraggles is obtained. Preliminary examination of manganese. The color tests mentioned here under are applicable for different oxidative state of manganese. Test for anions, permanganate or magnet. Test with sodium bismuth. A drop of extract is placed on a spot plate. 1 drop of concentrated nitric acid and a little sodium bimutate is added. The purple color of permagnetic acid appear. Test with ammonium peroxide disulfate. Test with ammonium peroxydisulfate. Take 5 drops of extract in a microcrucible. 1 drop of 0.1 N silver nitrate solution is added and stirred. A few milligram of solid sodium peroxydisulfate is added and heated gently. The characteristic color of permanganate appears. Test with sodium phosphate. To 0.5 ml of extract, a few drops of sodium phosphate is added. A pink precipitate appears. Preliminary test for mercury. Dear student, in introductory part we learned about mercury. Anyone among you could give me an answer that mercury is liquid or solid? Mercury is only metal which is present in liquid form, and I swear that all of you have seen that in your laboratory also, or in the laboratory thermometer as a bright silvery substance. The following chemical tests are performed for the examination of mercury. Reince test. The procedure of Reince test is same as you have performed in arsenic detection method. In these silvery shining deposits on the copper strip indicates the presence of mercury. After necessary cleaning, the dried shine copper strip piece is heated slowly in a Reince tube and the deposits on the cooler side is viewed under a microscope. Shining round globules of metallic mercury are observed. Test with diphenyl carbazone. A drop of the test solution is placed on a filter paper impregnated with a freshly prepared 1% alcoholic solution of diphenyl carbazone. According to the concentration of the mercury, a violet or blue fleck appears. Now we see preliminary test for nickel. Before knowing about the color test, you all should have to be aware of the fact that the poisoning due to nickel is very rare, but in some cases forensic scientists may be interacted with this kind during the examination, so the knowledge is very essential. The following tests are performed for the examination of nickel in biological matrices. Test with alpha nitroso beta naphthol, 1% solution in ethanol. 1 drop of faintly acidic solution of the extract is placed on reaction paper. A drop of reagent is added. A brown precipitate is formed which is soluble in hydrochloric acid. Test with dimethylglycosone. Reagent 1% solution in ethanol. 1 drop of the extract is placed on a reaction paper. 1 drop of reagent is added. The paper is holded over ammonia vapor. A red spot in case of test paper or precipitate on coloration is produced. Preliminary test for thallium. The preparation of extract from biological material is different, but the extract prepared by wet digestion may also be used for the following test. The following tests are performed for the metallic poison. Potassium chromate solution. To 1 ml of extract, potassium chromate solution is added. The formation of yellow precipitate indicates thallus ion. Ammonium sulfide solution. To 1 ml of extract, ammonium sulfide solution is added. Black precipitate appears in case of thallus ion. Potassium ferrocyanide solution. 1 ml of extract is made alkaline. To this, potassium ferrocyanide solution is added. Brown precipitate appears. Generally, confirmatory and instrumental methods are similar to each other, but they have a little difference. That is, instrumental methods are specific, qualitative, reliable and selective, but confirmatory test may be quantitative or qualitative in nature, which is generally crystal test. The instrumental methods for identification of metallic poison are as follows. For lead. Determination of lead in viscera by UV visible spectrophotometric method. In this, method, we need to prepare standard solution of different concentration and examine them under a UV visible spectrophotometer. We can also determine lead in blood by flameless atomic absorption spectrometry. For manganese, determination of manganese in biological matrix using atomic absorption spectroscopy. Determination in urine by inductive coupled argon plasma atomic emission spectroscopy. Inductive coupled plasma are generated from radio frequency magnetic wave induced by a water or air cooled copper coil looped around a quartz tube. Energy dispersive X-ray fluorescence spectrometry. The instrumental method is always used to the analysis of metals in soil and sediments and environmental samples of air and water. The EDXRF technique is rapid, non-destructive, required only very small sample preparation by microwave digestion or pulverization of sample. Mercury. UV visible spectrophotometer are used to analyze mercury in biological material. Determination of mercury in urine and viscera by cold vapor atomic absorption spectrometry. Flame atomization is not necessary for the atomic absorption spectrometry of mercury. The cold vapor technique described here requires a reduction vessel to produce mercury vapor. Determination of mercury in blood and urine by cold vapor atomic absorption spectrometry. Energy dispersive X-ray fluorescence spectrometry EDXRF. The instrumental method always used to the analysis of metals in soil and sediments and environmental samples like air or water. Nickel analysis in blood by inductive coupled argon plasma atomic emission spectroscopy ICP-AES. Energy dispersive X-ray fluorescence spectrometry EDXRF. This instrumental method always used to the analysis of metals in soils and sediments and also in the environmental samples. Thallium. Atomic absorption spectrometry is used for the determination of thallium in urine and blood. Thallium elemental analysis in blood or tissues by inductive coupled argon plasma atomic emission spectroscopy as an indicator of exposure. Forensic importance of lead. Historical record shows that lead water pipes and food containers were popularly used by the ancient Roman emperor, which became one of the cause for the disintegration and destruction of the Roman culture. Members of the upper class of society suffered from various physical and mental disabilities, and their women, in addition, suffered from sterility due to chronic lead toxicity. Suicidal and homicidal use is very rare due to long painful suffering before death. A rare form of chronic poisoning may occur through absorption of lead from an unremoved bullet lodged somewhere in the body. Lead is retained in the bones, teeth, hair and nails. The maximum amount is usually found in hair, especially the black hair of Indian women. Red lead may also be used as cattle poison. Forensic importance of manganese. Manganese is primarily found in the bones, liver, kidney. This metal is essential for our body, which helps the body from connective tissues, bones, blood clotting factors and sex hormones. Few milligrams of manganese can cause obesity, glucose intolerance, blood clotting, skin condition, low cholesterol level, skeletal disorder, neurological symptoms and even the hair color may change. Its alloy help stiffen the aluminum in soft drink cans, so poisoning may occur due to long-term use also. Forensic importance of mercury. Occupational exposure to inorganic mercury has occurred in mercury mines, chloroalkali plants, thermometer factories and in health service maintenance worker responsible for repairing broken sphygmomanometer. Non-occupational exposure to mercury occurs principally from dietary intake and to a minor extent from dental amalgam. Many foodstuffs contain small amount of inorganic mercury, but organic mercury compounds bioaccumulates in the aquatic food chain also. Accidental poisoning may occur in children from the use of ammoniated mercury in some bleaching creams and mercury in the main constituent of Paros serpens. It is mainly sold in the festival season, especially during Diwali, for the entertainment of children. When ignited, it gives out pungent smell and ash in the form of long tortuous figure resembling a snake, hence the name false. Ingestion of mercury chloride in teething powder has led to acrodynia, pink disease or swift disease in infant. Fish contamination. The early case of contaminated fish poisoning occurs in Japan in 1956, called as Minamata Bay disaster. This resulted from methyl mercury poisoning when mercury in a factory effluent was discharged into the bay. Forensic importance of nickel. Poisoning is rare. Parts of DNA can be silenced, not muted, leading to cancer. Reports of allergic contact, dermatitis, pulmonary and respiratory effects are there. Forensic importance of thallium. Thallium salts possesses many properties of an ideal homicidal poison because they are colorless, odorless, tasteless, freely soluble in water and produce toxic manifestation resembling natural disease. The commonest salt is thallus sulfate, which can be mixed with tea, coffee or juices. Accidental poisoning may also occur as a result when cocaine mixed with thallium is used. Atmospheric poisoning may occur as a result of coal burning power plant and from smelting copper, lead or zinc. On X-ray examination, opacity in liver may be seen. Chronic poisoning is seen among workers employed in chemical factories where thallium is isolated from pyrites residue. It is a potent rodenticide and used for killing rats and ants. It's a case related to thallium poisoning. Although this case is very old, but it is very important and taken from Textbook of Forensic Medicine and Toxicology written by Krishnan Vij, and it deals with the case of homicidal poisoning which was reported in the year 1927 when a series of homicides were committed by using thallus sulfate meant for killing rat, Zelo paste. It was mixed with butter spread on bread slice and administered to victim, of whom 7 died. Granion Case, which occurred in Britain in the year 1971, is informative. In this case, 2 victims died and other narrowly escaped death. The case was of forensic uniqueness in the sense that it was probably the first murder wherein the poison was detected posthumously in the ashes of a cremated victim. With this, we come to the end of all 5 important and interesting modules. At the end of this lecture, we could conclude that some metals are essential for our body, but its concentration plays a crucial role. If they get accumulated in the body, they may cause acute or chronic poisoning. In this lecture series, you have learned about the metallic poisons that are toxic to organism and how could you identify them in matrix by different identification methods. With all these information here, we come to the end of today's informative lecture. Do keep in mind what we have discussed today. It's time for you all to do some self-study. This is Professor Devashish Bose signing off. If you want to learn more and enhance your knowledge, you may log on to our website for MCQs, quizzes, LOR at www.cec.nic.in. Till then, goodbye.